Welcome to the video on z-scores. Let's start by talking about the definition of a z-score. A z-score is just a value that's calculated to show how far a certain person falls below the mean or above the mean. In other words, it's a value that's calculated to show how far below average or above average a person is. And more specifically, a z-score shows the number of standard deviations that a certain person's value falls below the mean or above the mean. And I think this definition will make more sense once we go over some examples. So, in a group of people, any person who's at the mean has a z-score of 0. If I'm teaching a class and I give out an exam, and the mean exam score of my class comes out to a 75, then any student who has an exam score of 75 would have a z-score of 0, because that person would be right at the mean of 75. A person who's one standard deviation below the mean, a person who's one standard deviation above the mean of the class would have a z-score of +1, because +1 means one standard deviation above the mean. A student who's one standard deviation below the mean would have a z-score of -1, because -1 means one below the mean. -1 means one standard deviation below the mean. A student with an exam score that's 2 standard deviations above the mean would have a z-score of +2, and a student with an exam score that's 2 standard deviations below the mean would have a z-score of -2. So, out of all of these students, the student with a z-score of +2 would be the furthest above average, and the student with a z-score of -2 would be the furthest below average. And a student with a z-score of 0 would be right at the average. A student with an exam score that's 3 standard deviations above the mean would have a z-score of +3. +3 means 3 standard deviations above the mean. A student with an exam score of, a student with a z-score of -3 would be 3 standard deviations below the mean. So I created these standard deviation bars to show that a person with a z-score of +1 is 1 standard deviation above the mean. A person with a z-score of +2 is 2 standard deviations above the mean. A person with a z-score of +3 is 3 standard deviations above the mean. A person with a z-score of -1 is 1 standard deviation below the mean. And a person with a z-score of -2 is 2 standard deviations below the mean. And finally, a person with a z-score of -3 is 3 standard deviations below the mean. Let's look at another example right here. If let's say that the population is a class that I'm teaching, and I'm giving the students in my class an exam, and I'm recording their exam scores. So I've recorded the exam scores of all of the students in the population of my class. If it turns out that the standard deviation of my students' exam scores was 5, then that would mean that, a person who's right at the mean would have a z-score of 0 like always. But a student in my class whose exam score is 5 above the mean would have a z-score of +1, because that student would be 1 standard deviation above the mean. Like I said, if the standard deviation of my class does turn out to be 5, then a student who's 5 above the mean would end up having a z-score of +1, because they would be 1 standard deviation above the mean. Now, if the standard deviation of my class turns out to be 5, then a student in my class who has an exam score of 5 below the mean would be 1 standard deviation below the mean. and their z-score would be -1. A person who has an exam score that's 10 above the mean would have a z-score of +2, because if the standard deviation of my class is 5, then this person would be 2 standard deviations of 5 above the mean. So if you started at the mean of my class and you went up by 5 and you went up by 5 again, you would get to this student right here. A student who's 10 below the mean would have a z-score of -2, because that person would be 2 multiples of 5 below the mean of the class. 15 above, a student who's 15 above the mean would have a z-score of +3, and a student who's 15 below the mean would have a z-score of -3. So all I'm trying to show you here is that the z-score is just a multiple of the standard deviation. If the standard deviation is 5, then a person who's 5 above is at +1, a person who's 10 above is at +2, a person who's 15 above is at +3, a person who's 5 below is at -1, a person who's 10 below is at -2, and a person who's 15 below is at -3. Now, what if the standard deviation of my class wasn't 5, but instead it was 10? In other words, I calculate the standard deviation of my class, and I find out that the standard deviation is 10. Well, in that case, a student who's 10 above the mean of the class would have a z-score of +1, because this person would be 1 standard deviation of 10 above the mean. 10 below, a person who's 10 below would be a z-score of -1. A student who's 20 above the mean would be at +2, and a student who's 20 below the mean would be at -2. So now we're dealing with multiples of 10. So if the standard deviation of my class, of the students' exam scores in my class is 10, then a student who's 10 above is at +1, a student who's 20 above is at +2, and a student who's 10 below is at -1. A student who's 20 below would be at -2. And you might guess that a student who's 30 above the mean would be at +3, and a student who's 30 below would be at -3. So now we're imagining that that a certain population of people has a mean height of 60 inches. That's the average height of the population, and the standard deviation of the population is 5. So if you recorded the heights of all population members, and you then calculated the standard deviation and the mean of the entire population, the mean would come out to 60, and the standard deviation would come out to 5. So, and down here, this isn't the entire population, but it's 5 people who have been selected from the population. They're just 5 population members that come from this population. What we're trying to figure out is what each person's z-score would be. We know what each person's height is, but we want to figure out what each person's z-score would be. Well, if these 5 people are coming from a population with a mean height of 60 and a standard deviation of 5, then this person with a height of 50 would be 2 standard deviations. This person with a height of 50 would be 2 standard deviations below the mean, and his or her z-score would be -2, because if the mean is 60, right here, if you go down by 5, and you go down by 5 again, you get to this person right here, who's 2 standard deviations below the mean. This person, who has a height of 55, would be 1 standard deviation below the mean, because they're one bar below the mean. So this person's z-score would be -1. When you go 1 standard deviation above the mean, you get to this person right here, who has a z-score of +1. And when you go up 1 standard deviation again, you get to this person, who has a z-score of +2. So if you start at the mean of 60, and you go up by 1 standard deviation of 5, you get to this person who has a z-score of +1. If you go up by 5 again, you get to this person who has a z-score of +2. If you go down by 5, you get to this person who's at -1. If you go down by 5 again, you get to this person at -2. Now there's actually a formula for a z-score. I haven't shown you the formula yet because I want you to get an idea of the idea of a z-score before I actually show you the formula. So I'm just trying to explain the concept of a z-score. For right now, I'm just trying to get you to understand that the z-score shows the number of standard deviations. Because remember, I think it's actually more important for us to understand what a value is showing than to understand how to calculate the value. Because these days in statistics, we have calculators and we have software that can calculate values. So it's really important for us to understand what each value represents or what it stands for, and not just how it's calculated. So I said that a z-score just shows the number of standard deviations that a person falls below or above the mean. So if these 5 people come from a population with a mean of 60 and a standard deviation of 5, then a person who's 10 below the mean, right here, is at a z-score of -2 because there are 2 standard deviations below the mean. A person who's 10 above the mean has a z-score of +2 because there are 2 standard deviations above the mean. Now any person who was 5 below the mean would be 1 standard deviation below and would have a z-score of -1. We don't have a person here in this data set. Any person who was 5 above the mean would have a z-score of +1 because they would be 5 above the mean, right? They would be 1 standard deviation above the mean right here. And if the standard deviation of the population was 10 instead of 5, then in that case, the standard deviation bars would change to 10. And now this would be -1, this would be -2, this would be +1, and this would be +2. So this person is 1 standard deviation below the mean because they're 1 bar below the mean. This person is 2 standard deviations below the mean because there are 2 bars below the mean. This person is 1 standard deviation above the mean because they're 1 bar above the mean. This person is 2 standard deviations above the mean because, well, they're 2 bars above the mean. So I use these standard deviation bars to show you that all a z-score is the number of standard deviations that a person is below or above the mean. So this is 1 above, 2 above, right here. If you go here, it's 1 below, here, 2 below. Here's another example of another group of 5 people. And remember, once again, the standard deviation is 10, which changes these bars down here. Now we'll get into the formula for a z-score. It's calculated by subtracting the person's individual data value by the mean of the group that they come from and dividing by the standard deviation of the group that they come from. Here's some symbols that we haven't quite gotten into yet. The X is the symbol for a person's individual value. This looks like a U, but it's actually the Greek symbol for mu, mu, and mu is the symbol for the mean of a population mean. This symbol is called sigma, and it's the symbol for a population standard deviation. Standard deviation of an entire population. So individual value, population mean, and population standard deviation. So let's go through an example of calculating a z-score with a formula. A person has a mean height of 70. They come from a population with a mean of 45 and a standard deviation of 7. So we would take the person's height of 45, their individual value, subtract it by the mean of the population, and divide by the standard deviation of the population, which is 7. We subtract on top 45 minus 70 is negative 25. We subtract on top first. After we subtract on top and we get negative 25, the second step is dividing by 7 on the bottom. So negative 25 divided by 7 is negative 3.6. So step 1, I subtracted 45 by 70, and I got negative 25. Step 2, I divided my answer of negative 25 by the 7 on the bottom, and I got this answer. So subtract first, and then divide second. Here's another example. A population has a mean height of 70 and a standard deviation of 7. So once again, we put the mean here and the standard deviation here. And the person has a height of 85, so that person's individual value goes right here. Subtract on top. 85 minus 70 is 15. Divide 15 by 7, and you get a z-score of +1. Also notice how, in the last example, this person with a height of 45 was below the mean. They were below average because the mean is 70. So a person who's below the mean ends up with a negative z-score. In this case, the person's height of 85 was above the mean because their height is above the mean of 70. So any person with a value above the mean ends up having a positive z-score. So if you're below the mean, you have a negative z-score. If you're above the mean, you have a positive z-score. So if a population, here's another example, if a population has a mean height of 60 and a standard deviation of 8, what would be the z-score of each of these 3 people who come from the population? Well, let's start with this person who has a height of 50. We would take their height of 50, subtract it by the mean of 60, and divide by the standard deviation of 8. 50 minus 60 is negative 10. Negative 10 divided by 8 is negative 1.25. Remember what I said, subtract first and then divide second. So this person has a z-score of negative 1.25, person 1. For person 2, take their height of 55, subtract it by the mean, which I told you is 60 right here, divide by the standard deviation of 8, which I told you right here. So 55 minus 60 is 8. 55 minus 60 on top is negative 5. We subtract first. Then we divide the answer of negative 5 by 8, and we get this z-score. Negative 5 divided by 8 comes out to this. So in this example, I'm actually providing you with the mean and the standard deviation. I'm telling you that the population has a mean of 60 and a standard deviation of 8. That's where the 60 and the 8 are coming from, right here. The only thing that's changing each time we do this is we're plugging in a different person's height. Here we took the first person's height of 50 and subtracted by the mean and divided by the standard deviation. Here we took the next person's height of 55 and subtracted it by the mean and divided by the standard deviation. Remember that the mean and standard deviation were provided to you right here. That's where they came from. For person 3, we would take their person's height of 60. We plug that person's height into the formula and subtract and divide. And in this case, 60 minus 60 is 0. Then we divide 0 by 8. And when we divide 0 by 8, we get 0. So those are the answers. Remember I told you that any person who's right at the mean will have a z-score of 0. So if the mean of the population is 60, any person with a height of 60 would have to have a z-score of 0 because they're right at the mean. And we can see here that the further below average a person is, the further their z-score will fall below 0. Because here when we start at the mean of 60 and we look at these heights that are further and further below the mean, the z-scores are coming out to bigger negative numbers. So the mean has a z-score of 0. The further a person is below average, the bigger of a negative z-score they'll have. The further above average a person is, the bigger of a positive z-score they'll have. Here's one other example. This is doing the same thing over again. Oh, but in this case, this is just an example in which you would actually have to calculate the mean and standard deviation yourself. I won't go over that one. But what I want you to understand is if a person's z-score is a big negative number, then that means that person is far below the mean. So a person with a z-score of, let's say, negative 12 is far below the mean. A person with a big positive z-score is far above the mean. So a person with a z-score of plus 12 is far above the mean. So if the z-score is a big negative number, the person is far below the mean. If the z-score is a big positive number, they're far above the mean. I'm going to skip over this one because I'm not going to focus on this. One last point I wanted to make is that if a population of people follows a normal distribution, then it's possible to predict what percentage of people in the population will fall between different z-scores. So if the people in a population follow a normal distribution like they do here, then it turns out that 68% of the population members will fall between -1 and +1. Actually, and this will be true regardless of what the standard deviation equals. It doesn't matter if the standard deviation is 5, 18, 15. This will always be 68% if the population is normal. 16% will be in here, below -1. 16% will be in here above +1. And if the population is normal, it turns out that 95% of the population will fall between -2 and +2 in here. only 2.5% of the population will have z-scores down here, and only 2.5% will have z-scores up here. So these are the most extreme low people in the population. These are the most extreme high people in the population. So if this was showing people's heights, and the heights were following the normal distribution, these would be the shortest 2.5%. These would be the tallest 2.5%, and 95% would be in this middle area. And it turns out that in the general population, IQ scores follow a normal distribution like this, in which most people have IQ scores in the middle, and fewer people have IQ scores in these lower and upper areas in the tails. So I'm saying that in the general population, IQ scores do follow a normal distribution like this, and we know that the mean IQ of the population is 100 in the general population, and the standard deviation is 15, which means that a person with an IQ score of 85 has a z-score of -1, because they're one standard deviation of 15 below 100, below the mean of 100. A person with an IQ of 115 has a z-score of +1, because they're 15 above the mean. They're one standard deviation of 15 above the mean. So what that means is that in the general population, 68% of people have IQs between -1 and +1. And well, if the mean is 100 and the standard deviation is 15, then a person with an IQ of 70 would have a z-score of -2, because if you start at 100 at the mean, you go down by 15, that's 85. You go down by 15 again, it's 70. So this would be an IQ of 70. If you start at the mean of 100 and you go up by 15, it's 115 right here. If you go up by 15 again, this is 130 right here. So in the general population, a person with an IQ of 130 has a z-score of +2. So here we have 70, and up here we have 130. So 95% of the population has IQ scores between 70 at -2 and 130 at +2. 95% of the population is between 70 and 130. Only 2.5% is below 70. Only 2.5% is above 130. And it turns out that if a population follows a normal distribution, 99.7% of the population, in other words, almost all of the population, falls between -3 and +3. Very few people fall below -3 or above +3. So in terms of IQ scores, 99.7% of the population falls between 55 and 145. Because if you start at 100, you go down by 15, it's 85. You go down by 15, it's 70. You go down by 15 again, it's 55. You start at 100, you go up by 15, it's 115. Go up by 15 again, it's 130. Go up by 15 one more time, it's 145. So 99.7% of the population falls between 55 right here and 145 right here. Hardly anyone is below, or very few people are below here or above here.